If alpha, beta, and gamma are the root of the general form of cubic equation ax cubed plus bx squared plus cx plus d equals to 0, we can from this root generate an equivalent equation to this general form by setting x minus alpha, x minus beta, x minus gamma to be equal to 0. And when we expand, I'm going to expand x minus alpha and x minus beta first, so that we have x squared minus beta x minus alpha x plus alpha beta multiplied by x minus gamma equals 0. Now if we proceed again with the expansion, we have x cubed minus gamma x squared minus beta x squared plus beta gamma x minus alpha x squared, then plus alpha gamma x plus alpha beta x minus alpha beta gamma equals 0. So when we try to regroup, we can see that by their degree, we can see that here we have x squared, and then we have the other x squared. So we can rewrite this as x to the power of 3 minus, let's take the alpha first, alpha x squared followed by the beta minus beta x squared, then gamma minus gamma x squared. Then let's take that of x, right? So we have plus, I take this first, alpha gamma x followed by this plus beta gamma x, and this plus alpha beta x, and lastly minus alpha beta gamma equals to 0. Then I can rewrite this as x cubed minus alpha plus beta plus gamma x squared, then plus here we do alpha gamma plus beta gamma plus alpha beta x minus alpha beta gamma, which is equal to 0. Now when we compare this to the original equation, there is a slight difference in their structure. And the first, in the general equation, it has a coefficient. The leading term has a coefficient of x. So x cubed essentially doesn't have a coefficient of 1. But here, it has a coefficient of 1. So we can divide this general equation by a. So when we do that, this becomes a x cubed divided by a plus bx squared divided by a plus cx over a plus d over a, and a 0 over a is 0. So we have x cubed plus b over a x squared plus c over a x plus d over a equals to 0. So we can compare this with this. So we can rewrite the general form as x cubed plus b over a x squared plus c over a x plus d over a equals to 0. So from here we can compare the degrees, right? We have x squared, we have x, and we have the constant. So let's do that. So when we compare, we can see that negative alpha plus beta plus gamma can be compared to the x squared we have here, which is a b over a, and this becomes alpha gamma plus beta gamma plus alpha beta is equal to c over a, and lastly negative alpha beta gamma equals d over a. So we can write this properly as alpha plus beta plus gamma equals negative b over a, and this is going to remain as it is, plus beta gamma plus alpha beta equals c over a, and this can be written as alpha beta gamma equals negative d over a. Now alpha plus beta plus gamma is what we refer to as the sum of roots. The sum of roots. Alpha, gamma, and all that, this is referred to as the sum of product. The sum of product of roots. And this is the product. So this knowledge is what we'll be needing to solve the next question before us. And the question says that given alpha, beta, and gamma at the root of this equation, find the values of this and the value of this. So this is what we're going to do. I would recommend that you have your sum of roots, sum of product of roots, and the product of the roots from the given equation. So we have 2x cubed plus 3x squared plus 4x plus 5 equals 0. And we know that alpha, beta, and gamma are the root. So we know from our understanding that alpha plus beta plus gamma is negative b over a. So in this case, this is a, this is b, c, and d. So we have a negative 3 over 2. And the sum of the product of roots is alpha beta plus beta gamma plus alpha gamma, which is c over a. In this case is 4 over 2, which is equal to 2. Again, the product of roots alpha, beta, gamma is negative d over a. This is equal to minus 5 over 2. So let's leave this, okay, and come back to the question. So for the first one, we have 1 over alpha plus 1 over beta plus 1 over gamma. So we can find the LCM, and the LCM is going to be alpha, beta, and gamma. This is beta gamma, this is alpha gamma, and this is alpha beta. Now coming back here, we know what alpha, beta, beta gamma, and alpha gamma is, which is 2, which is similar to what you have here at the numerator. So the whole of the numerator becomes 2. And the denominator, which is alpha, beta, gamma, has been obtained as minus 5 over 2. So we say minus 5 over 2. When you simplify this, you have minus 4 over 5. That has been settled. For the second one, however, alpha squared plus beta squared plus gamma squared. If you look at what we've obtained previously, we don't have anything we can leave direct from here. So there's going to be a little bit of algebraic manipulation that you're going to do. So since we need the square of alpha, the square of beta, and the square of gamma, we can do something. We can start off by squaring alpha, beta, and gamma. the sum. So when we do this, we have alpha plus beta plus gamma, alpha plus beta plus gamma. And when you do this, you're going to have alpha squared plus alpha beta plus alpha gamma plus beta alpha, okay, plus beta squared plus beta gamma, and then it goes on and on, alpha gamma plus beta gamma plus gamma squared. And when you look at this very well, you will see that we have alpha squared, beta squared, gamma squared put together. We have alpha squared plus beta squared plus gamma squared. And we have alpha beta and beta alpha, which are literally the same, so we can sum them up as 2 alpha beta. And the same thing goes with alpha gamma, so we have plus 2 alpha gamma. And lastly, the same goes for beta gamma, so we have 2 beta gamma. Well, that's it. So this becomes alpha squared plus beta squared plus gamma squared. Then we'll bring out the 2 alpha beta plus alpha gamma plus beta gamma. Remember that this is where we are coming from, right? So because what we needed in the first instance is x squared plus alpha squared plus beta squared plus gamma squared, then we can take all of this to the left hand side. So we have alpha plus beta plus gamma all squared minus 2 alpha beta plus alpha gamma plus beta gamma equals alpha squared plus beta squared plus gamma squared. Now with this, we can go back to the sum and all of this that we've previously obtained, and then we substitute it into the equation. Okay, so we have our alpha plus beta plus gamma as minus 3 over 2 all squared minus 2 times 2, and that is the alpha squared plus beta squared plus gamma squared. So this is 9 over 4 minus 4, and that equals to minus 7 over 4. That is alpha squared plus beta squared plus gamma squared.